Okay, so we've got log base 11 of x plus log base 11 of x plus 1 equals log base 11 of 6, and we need to solve for x. What do you think we need to do? Get x by itself? I do need to do that, or at least solve, somehow I gotta solve for x. I don't know if it's possible to get it alone by itself. Do you guys remember this? If we did this the other day, log of x equals log of 2, and the answer is x has to equal what? Because what can I do with the logarithms? Right, if you have log of this equals log of that, that's only true if the inside equals the other inside, so you might as well just drop them and solve that. Well, there's nothing to solve there, it's just x equals 2, yeah? Okay, so if I had one logarithm equals another logarithm, I'd be good. Do I have one logarithm equals another logarithm? Could I make this one logarithm? How? When a log is separated by another log with addition, how do I combine them? With multiplication, right. If log of A plus log of B is log of A times B, and vice versa, right? What if this is a minus? Then it would be what? Division. So let's do this. They have the same base, so log base 11 of x times x plus 1. Were you foiling it out already? Or distributing? Okay. So log of this plus log of that is the same thing as log of this times that equals log base 11 of 6. So now what can I do? Well, yeah, I'm just going to go ahead and cancel out what? Right, because I don't need them to solve the equation anymore. So the equation is, when does x squared plus x equals 6? Now, can I just factor out an x right here and start solving from there? The only way that works is if you have it set equal to 0. So this looks like a quadratic to me. I've got a quadratic term, a linear term, and a constant term. I need to move this where? Over. So I've got x squared plus x minus 6 equals 0. Can I solve that? How? Factoring, right? And quadratic formula is fine, but I can factors of negative 6 that add up to positive 1. Negative 2 and positive 3. So x minus 2, x plus 3 equals 0 when x equals what? 2 and negative 3. Yeah? Okay. So 2 and negative 3. However, the question is, are they both answers? I hear a yes and a no, all from the same person. Okay. But at least he's offering, he's maybe thinking about it. Okay, what could, let's do 2. Log base 11 of 2 plus log base 11 of 3 is the same thing as, so log base 11 of 2 plus log base 11 of 3 is log base 11 of 6. Well, I mean, that makes sense because you can multiply, right? Okay. You could also type it in, make sure in your calculator, that would be fine. So what's the issue with negative 3? Log base 11 of negative 3 plus log base 11 of negative 2. You would think only... Can you remind me what the log graph looks like? Okay, here's exponential. Here's logarithm. Right? So what's log at negative 2? Where is this function? Where is it going? It's getting closer and closer to what? Is it actually hitting it? Is there any evidence that log exists over here? Log of a negative number does not exist. Meaning this right here, negative 3, This is a solution. This is called an extraneous solution. Yes, it's a solution to this equation, but it's not a solution to this equation. Okay? So I only have one real answer, and it's 2. No. If you got a negative and when you plug it in, you have a log of a negative. Because see right here, what if I had had log of, and it had somehow it had a negative in there, or this had been log, or like 1, let's say 4 minus x. Well, if x is negative 2, it's fine, right? What would be an issue there? Like 5 would be an issue, right? 6 would be an issue, 7 would be an issue. And those are positive numbers, right? It's if when you plug them in. Right. If you sub it in and you get log of a negative number, then it's an extraneous solution. Okay. Alright, so there's that one.